Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 5, longest palindromic substring. So given a string S, return the longest palindromic substring in S. So you'll be given with a string as you see in the example over here. So here is one of the input string BA. So there are two palindromes which are of size 3. Of course there are smaller palindrome than that, but the biggest one we can see is BAB and ABA, right? Both are of size 3 as you can see. So you can return either of the one. So BAB or ABA, both are valid answers. So we need to identify the longest one and we need to return that back, right? So the string could be of size 1000 characters also. So there is a possibility that you get a very big string wherein you have multiple palindromes, and essentially what happens in a brute force algorithm for a problem like this in Leetcode is that you will often get a timeout, right? So we are going to see an approach which is pretty much optimized, and we are going to come up with the code as well for the same. So here is another example that you need to understand over here, that we have a string like A and C, right? So a single character by default is a palindrome, right? If I take the character A, it is A from both front and back, right? It's the same, right? So here we have two palindromes A and C, both are of size 1. You can return either. So here the output is A, it could be C either. There is no harm in sending C back, but yeah, we have to return the longest one. So in this case above as well, what we have seen is that there are this B and A itself is also a palindrome, right? So this B A D, these are all single character palindromes as well, but the longest one we see is that BAB. So we need to return BAB or ABA, either of the one, which are of size 3, right? So yeah, we are going to check out the solution, but as I always recommend, do give it a try yourself. Do try to solve the problem, at least try the brute force approach, and then we are going to see the optimized approach over here. There are multiple ways to solve it, and we are going to check more than one solution for it. Maybe I'll create 2 separate videos for the same, but let's head over to Leetcode and check out the solution. So here I have taken the same example from Leetcode. So before we proceed, let's understand few of the basic things. So normally in a palindrome, what do we do? So let's say I have a palindrome like this. The basic understanding is very simple, that we take a left pointer and we take a right pointer. The left starts going towards the right and the right starts going towards the left. And if they crosses each other, right, we stop at that point. And at any point, if we see a violation, that if the characters are not matching, then we are going to say it's not a palindrome. So we'll step the right once we have checked towards the left, and for the left, we are going to move this, and then we are going to move right once again. So right will come here and the left will go there, and this is one of our criteria wherein we'll say that okay, we are not going to proceed any further, right? So this is one of our example, right, wherein the pointer crosses each other and we stop. And there could be another example over something like this, wherein again we have the right at the rightmost edge and leftmost edge, and we are going to move the right towards the left one towards the right. So here what we see is that we stop at this point here. We do not allow them to cross. So why are they basically stopping over here? Because they are able to meet. So if you remember in this case, what happened, they never met, right? That's because this is of even size, and here it is, here they met because they are of odd size. For odd, what we have seen, that there can be a single character which can be different. So in a even string, what we can see is that we can partition it to half. For odd one, we cannot. And the middle character is one single character which contributes to both the partition, the left and the right, both, right? So now this could be one approach. The other approach could be we start from the middle and we can go towards the edge, right? So we are going to take this scenario over here. So what we'll do in this case is the right will start from here, the left will start from here, and the right will go towards right and the left will go towards left. This is how also we can find it, right? The reverse way, right? And same for this guy, the right and left will start from the same position, and right will move towards the right. So it will go towards this side, the left will go towards this side. This can also be done. It's also going to yield the same result. But how this is going to help us, we have to understand over here. So what we are going to do over here is we are going to basically iterate over this string, right? So let's put down the index for this. So instead of telling him that this is my starting position, what I'm going to tell him is that this is the middle of my string. How big a palindrome can you make from here? So what will happen over here is we will be passing the string as is. So the string is coming as a parameter, which is always going to be BABAD, right? Throughout this example. And what we are going to do at the same time is we are going to pass the left So the left and right initially, so when I start iterating, my I is pointing at 0th index, right? So I'm going to pass a 0 for both, telling him to find the biggest palindrome that he can find, considering that this is the middle of the palindrome, right? And I am checking this for an odd size palindrome because you can see that the left and right both are pointing to the same place in this case, right? So we are going to take the same example and see how far we can go over here. So what I'll do is I'll pass these two pointed to the same index, and right will go towards the right and left will go towards the left. So at this point, I can say the biggest palindrome I can make is a 1, right? Because B itself is a palindrome and both left and right is pointing to the same character, so it's fine. So now what will happen is the right will move towards the right and the left will move towards the left. So the left will come over here. So this becomes my one of the breaking conditions, saying that I cannot proceed further, and the biggest palindrome that I can make is of size 1. So this function will return a 1, right? So I is still standing at 0, right? So I have checked for the odd case over here, and now I have to check for the even case. Like now what will happen for the even case is it's very simple. So instead of 0 0, what I'm going to do is I'm going to pass 0 and 1. So what I'll do is I'll put my left over here and I'll have my right over here, and I'll tell them to expand and see how far they can make. So at this stage only I can see that I cannot make a palindrome, right? So I'm going to send back nothing. I cannot make a palindrome here, so I'll send back a 0, right? So the best answer that we have received is a 1 as of now, which is the single character B. So now what will happen is, again, I will move on. So now see how things will start making sense over here. So what I'm going to pass is a 1 and a 1, telling that both left and right is at 1, and see how big a palindrome you can make. So what happens basically over here is now we get this, right? So I can see that, okay, I can make a 1 because both are fine. Now the right will move towards the right. So right will come over here and left will come over here. I can see, yeah, I can still make a palindrome. Both are B, right? So immediately I know the size is nothing but 3. See that how I have found it, right? And then I'm going to push this to the out of index, and I'm going to put this over here. So I returned that with a 1 and a 1, the best I could do is a 3. So my previous best was a 1. I changed that to a 3. So I said, okay, I have found a good answer as of now. So now I'll start with a 1 and a 2. So odd size I have checked. Now I have to check for the even side. You can check the simplicity of the solution, how we are checking the even one so easily. Now I am just going to proceed with, so B and AB is not a match. So directly my loop will never go, right? Until and unless we have a repeating characters like B like that. For those cases, it will, so if it is a B like that, so the odd one will find a 3, the even one will find a 2, right? So what we are basically doing over here is we are iterating over the string ones, and then from every position, what we are doing is we are expanding, right? And this will have a reduced complexity compared to checking all the n square strings, right? Here I am not checking for an n square string. Basically here I am checking for n strings. So what does it makes all the difference? The difference is that I am telling him that I am giving you the center you expand, right? Instead of telling him then this is a string, you check it, it's a palindrome or not, I am doing the reverse thing over here. I am giving you the middle and you find it out how big a palindrome you can make for me, right? And the bigger you can make, it's better for me, right? And if you can't make it will be found out very fast, right? So basically our savings comes from n squared to n. So I am basically checking from n string. And if you see, and you might say that you are checking twice, right? I'm making a check for the odd and I'm making a check for the even, right? So for both, what will happen in the worst cases, it can go to O n, right? Order of n, right? I'll go over the entire string. So even if you do that, what will end up doing is order of 2n, right? So if it's an order of 2n, that's essentially mean it's order of n, right? We are not doing an n square solution over here. Order of 2n and n square is a totally different thing, right? Both has a both varies to a great extent, right? So it's a much more optimal solution that we are talking about over here. But yeah, few things that we have not discussed over here, that once we hear back from our function, we need to store them and we need to appropriately find out that where the string is starting from and all those things that we are going to see during the code, right? So let's head over to the Leetcode and let's check out the solution. So here we have been already given with a function that we need to implement longest palindrome. So what we are going to basically do here is to check a few things and call a function which will be expanding it from the middle and checking if it's a palindrome or not, right? Okay, So what we are going to do is we will introduce the variables as and when we need it. So let's start with the basic part, that we are going to start from 0 and we are going to go till the length of the string, right? And what we are going to do every time is to check for the even and the odd palindrome, right? So let's create a function first, which will help us to do that, right? So here we have created the overloaded method, which is having the same name. Of course, it's overloaded. So we have just two extra parameters, left and the right. So basically, what we are going to do is we are going to move the left towards the left side, right? So left should always be greater than 0. And if you look at the solution, what will happen is that left and right will never meet because they are going in the opposite direction, right? So we don't need that check that we generally do in a palindrome. And the right should be less than s dot length, right? And what we are going to do over here is we are going to continuously check. So what we'll do is we'll return an int from here. Basically, we'll return the index and we'll take care of all those things inside the loop, right? So what we are going to do is we are going to break out of this loop when we see that it is s, right? S dot caret left not equals to s dot caret right. That's the moment we are going to break this loop and we are going to return. So right and left has been moving, right? So we need to return right minus left, right? So in this case, what we'll be doing is, so what we have seen is that B and B is matching over here. So we are going to move right further and left will eventually come to an index like -1, right? And what we are doing is basically we are doing a right minus left. Now if you see over here, what we get is basically 3 minus of -1, right? So we basically get a 4, right? Which is incorrect. So basically what we need to do is we have to do a -1 before we send the return back, right? Because you are stopping where you have exceeded, right? So you have to do a -1 in order to have the right result, right? And it's a 0 based index, that's why you don't have to do a -2, right? So we are going to do the same thing in the code as well. So we are going to return right minus left -1. So this is going to be our palindrome function, the main palindrome function. Now what we were doing previously was to call this function twice, right? So we are going to call longest palindrome and we are going to call with s, and we are going to call with I and I. So this is for the odd one where the left and the right is pointing exactly to the same index, right? And we need to check the same thing for the even one as well. So for the even one, we're just going to do a I plus 1. So it just moved the right one step ahead of it, right? So we are going to get two lengths from here, right? So let's say we call this as odd length and we call this as even length. And of course, when we have two lengths, we are going to consider the one which is bigger, right? So we are going to put a variable over here called length and we are going to take the max of both the lengths that's been returned to us, right? So odd length and even length, right? We are going to take the max. And also we need to keep a track of the max, right? Otherwise, how do we know that we had a better result previously or not? So what we are going to do is we are going to have a max and we are going to put the max into 0. So another thing is important for us over here, that is to know the start index and the end index, right? Because we need to send a string back. It's not about the index that we can send back. We have to send the string back. So let's put them to 0, 0. So the first character itself, so it's a palindrome by default, but we are going to see if we can find a better result. So now what we want to do is we got the length, right? We are going to check over here if this length beats our current max or not, right? So if we have a better max, we are going to update our max, right, with length. And at the same time, we need to reinitialize both our start and end. And now how do we get the start and the end? Let's say we have sent this index, right? over here 2 was our index, and in return what I get is a 3, right? The index I is pointing over here, and that is nothing but the middle of the palindrome. So what we are going to do is, I know the middle, I know the length, so I have to, I know I'm this I is standing at the half the position of the palindromes. So if I divide by 2 and I subtract that value from I, so let's say 2, and I have a length 3. So if I make a half, so I know that this is the half of the palindrome, right? So I'll get a 1.5, drop the 0.5, we get a 1. I know that I is at 2, so if I reduce if I reduce by 1, I will go to the index 1, and if I increase by 1, I will go to index 3, and that's where my palindrome starts and ends, right? It has to be true because we know the middle and we know the size. So we are going to do the same thing over here. So what will happen for start is basically we know that that max is our result, right? So you can say max minus 1 by 2. Whatever value I get over here, I am going to reduce that value from mine. That will give me my start, right? And same goes for end, that we are going to do a max by 2. This is going to give me the start in index and the end index at the end of the loop, right? So what I'm going to do at the end is to return. So I'm just going to do a substring over here, and I am going to put the start and end, and of course it's 0 based index, so end plus 1, right? So we are getting the best start and the end index, best in the sense the longest one, right? And at the end, so continuously we are comparing with max, right? So we'll have the best result at the end, and we are going to just do a substring and get that done, right? So let's run this code and check how it goes. Okay, so spelling, I guess. So my bad, I forgot this part. So right has to be increased and left has to be. So right will go towards the right, it will increment, and left will decrement. So left minus minus and right plus plus. Yep, it's been accepted. It's 0 millisecond. Let's do a submit and check like how it goes for the wider range of test cases. Yep, we are good. We are better than 91% of all the submissions with 23 milliseconds time being taken for all the test cases. So yeah, I hope once again you got the solution, like how we are leveraging the middle of the palindrome rather than we are starting from both the ends the traditional way, right? So that is the whole point over here, that how we optimize things, right? And how we came from n square solution to a order of n solution. So once again, this is one of the approach. I am going to create one more video on the same problem, wherein we'll be seeing a dynamic programming approach, which is not that efficient, but it's good to understand, because that's a very a nice solution as well, right? So we are going to discuss that as well and see how that goes as well. So do let me know what do you think about the solution. Do drop a comment, like, and subscribe as well if you haven't done so. Share with your friends, and I think we have already covered the complexity part over here as well, so we are good for this problem. So check this video out, and by then I'll make the next one ready, the dynamic problem one. So thank you once again for watching, and have a great day. Stay safe. Bye bye.